Thank you so much, Abbas, for the opportunity to showcase what Energy Minerals Division is doing these days. And it's becoming a lot more important because we're helping in the development in geology and technology related to critical minerals and rare earth elements, for example, for battery storage, what we've heard all for the last 2 days. We also have other committees like geothermal hydrates, hydrogen, helium, uranium, and new technologies in oil and gas shales and tight reservoirs, bitumen and coal bed methanes. And I wanted to just highlight EMD. For example, we have a website associated with the APG website. Right now, Justin Birdwell is the president, past president. And we also have a Facebook website. And what's really important is a really cool YouTube website where we have 3 webinars that we conducted, recorded there and for anybody to listen to or watch. Also have a LinkedIn website, of course. Wanted to talk about very quickly about some of the non-carbon alternative energies that we have, and most importantly, the short course, the webinar that we're currently conducting, the critical minerals in rare earth elements, that is headed up by Ashley Douds, was formed by Jesse Edmondson under the tutelage of Edith Wilson before, and it's become a very important committee that is composed of quite a few committee members that range from industry to government. The critical minerals are vital to aerospace, defense, and energy storage technologies like the rare earth elements, graphite, lithium, cobalt, and vanadium. In our committee, the Critical Minerals Committee is interested in the professional opportunities this emerging industry presents to our organization, especially those related to their rapidly growing green energy market. So this committee does a lot of research and posting this online, and you're welcome to always contact myself, Justin Birdwell, or Ashley Douds about that. We also have a uranium committee that has been very active under Michael Campbell's leadership. He recently stepped down, and we are looking for a committee chair. But some committees members are still very active on it, and you can always look it up on the website. Bruce Cutright is the committee chair for our geothermal energy committee, has been very active. We recently actually had a one-day workshop in conjunction with APG and the Bureau of Economic Geology that was very well received, very active on that side. Recently also founded a hydrogen committee under Geoff Ellis at USGS that we added to our range of alternative energies. And then we have the classic committees, for example, heavy oil and bitumen that is run by Ian Kirkland, the coal and coal bed methane that was run by Bill Ambrose, and the gas hydrates by Tim Collett, USGS. And one of my favorite committees that I've been very much involved with were the tight oil and gas committee that is currently run by Lucy Coe. But I wanted to now hand off this screen to Ashley Douds, who will show you some of their amazing research they started to do on black shales, not only up in the Pennsylvania, but we recently also looked at some of the Texas shales. So stop sharing my screen, Ashley, and you can take it from there.
Okay, so you can see my screen okay? Okay. So thank you. That was a great, oh, I have the energy opportunities. I'm sorry about that as my background. But we are going to be having a panel about critical minerals here tomorrow that might be interesting for people to take a look at. But I couldn't have a better segue for what I'm going to be talking about because we are looking at pivoting from all of the research that we've done on black shales and industry and looking at how we can apply that information to critical minerals. And so I've co-founded the company Wildlands Research with Randy and Scott. And we're really interested again in taking that information that we've learned and understanding how we can predict enrichment of critical minerals in shales. And so I just wanted to make sure that we acknowledged our sponsors. We like to say that our project is on our own time and on our own dime, which definitely going out in the field and doing the analysis and interpretation is. But we do have generous sponsors who are helping us with our analytical work, as well as some of the field gear that we need in order to get all the outcrop data back to the lab. So an outline of what we're going to talk about. So just going to briefly talk about why we're doing this work, what data are available, how we're tackling the project, what we know right now, and what we see as the path forward. So obviously we've had a lot of discussion about critical minerals over the past couple days, and we really feel that sedimentary deposits are going to be a new frontier for this. So, the IEA has come out with their estimates on how much total mineral demand just for clean energy technologies. And in 2040, their estimate is either 2 times what we needed in 2020 or 4 times. And I'm not even showing the net zero carbon scenario. Let's see. And so if you think about it, we're just back at the resource triangle again. If we need to have that amount of critical minerals, we need to go after some of these larger volumes, difficult to develop resources. And so, obviously we've gone after the high quality stuff and we're still looking at ways to find a lot of that stuff. But as we move down the triangle into higher prices and additional technology that's needed, we're going to be going after these resources that are at this basal part of the resource triangle. And so, we've seen it happen with coal bed methane, tight gas hydrates, and we know what happened with gas shales in our industry. And so we think it's really time to take our great knowledge from shales and apply it to predicting critical mineral distribution. And so really, the bottom line is that the industry is already mining. The oil and gas industry is already bringing up literally tons of cuttings, black shale cuttings, to the surface. If you look at an average well, we're getting about over 200 tons of cuttings per lateral. And if you multiply that by a 10-well pad of 7,000-foot laterals, which is pretty typical, you've got almost 1,000 tons of cuttings that are coming to the surface. And if you multiply that by the values that we see from some of the black shales, this is an example from the Beaver Meadows core, which is a publicly available core for the Marcellus. You can get some, pretty good numbers for critical minerals. And again, these are metalliferous black shales, so we understand that there are geologic reasons why these critical minerals are being concentrated in these shales. So again, when we look at a drilling target, we're often identifying it by the hydrocarbon saturation, the organic content, and the favorable porosity that we see on the logs. Well, that just so happens through geologic processes to be where battery metal content is enriched. And so we think it's time to take advantage of that information and work on predicting it in the subsurface. So this is a fantastic data set that is made available by the USGS. It's their global black shale database. And I just put on here a select number of metals of interest. And I've highlighted a few of the concentrations that are listed on there, as well as their normalized value to the post-Archean Australian shale. And you can see that some of these numbers are impressive. Again, it's a great database. It gives you a great high-level understanding of the geochemistry of these shales, but it doesn't have enough information for us to be able to predict why these concentrations are so high. And so that's where, oil and gas industry geologists can come in to the picture. And so we really feel that our knowledge can help us predict where these critical minerals are concentrated, and then be able to outline metal concentrations in the subsurface so that we get an idea of what the resource is. And so if we just jump into the project that we're working on, so we kind of call this like an open source project. So we're very open with all the work that we're doing on this project. We want to show people how we're developing a workflow that we think is going to be applicable to other shales. And we're starting at the outcrop level. This is the Dunkirk Shale, which is present along the Lake Erie shoreline in New York. Let's look at the stratigraphic column. So it's an Upper Devonian shale. Here's the Dunkirk right here. And you can see that the sequence from the Marcellus up is basically a lot of interbedded gray and black shales. Now, in addition to having great outcrop exposures, another reason that we decided to start with the Dunkirk Shale is because there's been a lot of fantastic work done, especially by Baird and Brett, and we're relying heavily on the work that they've already done to identify the geologic picture for us, so that we can then marry in the geochemistry and then the geologic processes that we identify to concentrate these metals. And so this is their cross section, and we're going to be throughout the process of the project revisiting most of these sites. The red bars here indicate places where we've already collected outcrop data, but we have not received all the analysis back yet. And so what Randy and Scott are able to do is go out to these outcrops once they've gained permission from the landowner, and they collect two cores. And so one core is boxed and preserved so that we can go back after the geochemistry is done and understand exactly what's going on with that portion of the core. And then the other one is cut up into 1 centimeter pucks and sent off for analysis. And so a very important part of what we're doing is the statistical work that Scott is working on. So he has identified the 3 phases of the project that we're going to be going through. Right now, we're still in phase 1, but already Scott has done a ton of work to identify how many samples we actually need to collect in the field so that we have a good representation of the variability within that horizon, as well as the length of time that they need to use the XRF gun on each individual sample so that we're getting a good representation of the metals that we're interested in, but not spending too much time on each individual puck. And so this will be a lot of the exciting side of it on the statistics end, which is, we're going to be able to identify some of the geologic processes and some of the lithologies that are associated with certain metal accumulations in these black shales. As I said, this is a very open project, so all of this information is available on our website. Scott has made a statistical dashboard. You can go in and you can change any of the axes. You can look at all the different elements that we've collected, and as we get more information, we're going to be adding it on there so you can see the same type of stuff that we're seeing and kind of track along with our progress. And so, the big part of this is identifying the processes, the geologic processes that are concentrating these metals. And some of the ones that we think are going to be impactful specifically in the Dunkirk include diagenetic processes like burn down, where you actually have an oxic front that's moving through the anoxic pore waters and remobilizing the metals and concentrating them into very thin bands within the now gray shale interval. And then the sedimentological ones, such as lag deposits. So anytime that we're seeing, concentrations of pyrite in the lags, we know that that's a good indication that there's probably going to be some metals there. So just to walk you guys through some of the data that we've gotten back so far, so that you can see some of our progress. So this outcrop location is our farthest west, our most distal part of the project, and it's called Point Grosset. And so you can see that we're collecting data from the Hanover Shale and into the Dunkirk Shale. And so I have on here the average log concentration of different metals so that we can see the stratigraphic variability as we go into different parts of the shale. And so as we get closer to the Black Shale, we're starting to see that some of these metals are concentrating and actually reaching some pretty high levels as you get into the pyrite lag portion of the Dunkirk Shale. And so this really highlights the importance of understanding the stratigraphic variability of the metal concentration so that we can predict where these are going to be in the reservoir. And of course, just as important is our ability to predict and see how it changes in these shales. So this is the one that I was just showing you on the previous slide. And here's two other outcrop locations where we have data back so far. And what you can see is that we do see some increases in the metal concentrations as we get into that basal pyrite lag again. And we also see it associated with individual pyrite-rich beds in the gray shale. And then we also can make some observations, which that's exactly what they are at this point, because we need to do more work to tie it to the geology. But we see that once we get into the Black Shale, we have, pretty straight line metal concentrations, with the exception of arsenic that seems to be decreasing and zinc that seems to be increasing. And it is something that we can follow from outcrop to outcrop. So it does seem to be a significant portion of, it does seem to be a geologically significant thing that we need to understand. And so just to wrap this all up, basically we think that there's a lot of opportunity with all the work that's been done over the decade plus that we've been drilling shales to tie that geologic information into understanding the distribution of metals in the subsurface. And there's a lot of opportunity because there's a lot of basins out there. And so, what we're doing is we're building that workflow. We're making it available to everybody so that they can see what our progress is and hopefully have a lot of communication and interaction with folks about, what their thoughts are on the project. And we think that this is going to be a good kind of, standard workflow maybe for us that we can move into other basins. And so we'd really like to connect with others. So please make sure you check out the website. Again, the statistical data is out there so you can play with it. And we look forward to hearing feedback.